torque on a dipole in a uniform electric field. Say for example, I have a dipole AB with plus Q charge and minus Q charge with a length 2A. Let this dipole is placed in the uniform electric field E. Now that is the direction of electric field. Now, if we place any charge in the electric field, then it experiences a force F is equal to E into charge Q. Therefore, if I consider plus Q charge, then a force of F plus Q is acting on this charge of the dipole, say along this direction. Similarly, a force of F minus Q acts on another charge, that is minus Q here, but that should be in opposite direction as it is minus Q. F plus Q here and F minus Q here, both are acting on the same dipole but in the opposite direction. Since magnitude of the charge is same, magnitude of the force must be same but in the opposite direction. This causes, that means two equal charge forces acting on the same dipole but in the opposite direction, therefore that must give couple, which causes torque. That means when you place the dipole in this uniform electric field, it starts to rotate due to the torque. Now question is, what is the value of torque? The magnitude of the torque. Magnitude of the torque, it is given by magnitude of any one of the force. I will take this one as F plus Q into, right, the perpendicular distance between two forces, perpendicular distance between two forces. Now with respect to this diagram, the magnitude of the torque tau is equal to F plus Q into perpendicular distance. This is the first force, this is the second force. Okay, so therefore perpendicular distance will be AC, A into C. That implies torque tau is equal to, now magnitude of this force. Now F is equal to EQ, therefore here also it is E, field strength, into charge, that is Q. Since both are having the same magnitude, I will take any one of them, that is Q, into, now what about AC? Now in this equation, in this diagram, sin theta will be equal to AC divided by AB. That is, sin theta is equal to this length AC into 2A. AB is 2A, that implies AC will be equal to 2A into sin theta. That means here AC 2A into sin theta. That implies tau is equal to, now 2Q into 2A, charge into length of the dipole, that must give dipole moment, therefore it should be E into dipole moment into sin theta. So this is the expression for the magnitude of the torque. Now since electric field and the dipole moment both are vector quantity, so therefore it is the product of magnitude of two vectors into sin theta, therefore there should be the cross product between E and P. If this one is cross product, then that must give vector quantity, that is tau. Therefore tau is the vector quantity which is given by E cross P. This is the vector form of the torque. Now if I consider different cases here, That means, say for example, if the dipole is along the direction of the electric field, that means instead of placing like this, if I place the dipole along this direction like this, then what happens? Then, right, this theta becomes 0. Case number 1, if theta is equal to 0, that is dipole perpendicular to E, then tau will be equal to EP sine of 0 or is equal to 0. Therefore, torque will be minimum if the dipole is along the direction of the electric field and its value will be equal to 0. Now what happens if I place the dipole perpendicular to the electric field? In that case, theta will be is equal to 90 degree, that is dipole, sorry, here should be along, here should be perpendicular. Then tau will be is equal to EP sine of 90 or that's equal to E into P. Therefore, that gives the maximum value for the torque. The minimum value of the torque is 0, that is if the dipole is along the direction of the electric field, and maximum value will be EP when the dipole is perpendicular to the direction of the electric field.